So in this video, we're going to talk about something called the rational zero theorem. So let's break down these words. So rational means fraction. Zero, so a number that I plug in and I get zero. Theorem is a rule. So this rule comes into effect when I'm looking to factor a polynomial. And what it helps me do is make a list of possible factors so that I'm not just randomly guessing and checking. I'm checking using synthetic division from a list that I've created. So if I have an expanded polynomial with integer coefficients, then if I'm trying to factor this, so let's give ourselves an example polynomial. Let's say f of x is equal to 6x squared plus, 5x minus 4. If I'm trying to factor this and it's going to factor nicely, then I know that my first two initial values are going to have to multiply to make 6x squared. My last two numbers are going to have to make -4. Well, the only possible integers that I could come up with to make 6 are either going to be 6 and 1 or 3 and 2. To get 4, I'm either going to have -4, +1, +4, -1, -2, +2, +2, -2. So if I was going to say that those end up creating my zeros, well then that would tell me that my x value is going to be equal to this number divided by this number. Well, these numbers here were my my factors of -4. So I would have factors of -4 divided by these numbers here, which are going to be my factors of 6. So that's what we've broken this down to here. So P over Q is a rational number in simplest form, and if it's a zero of my function, then P, so this number on top was the first number I moved over, it's a factor of A naught. So let's do some highlighting here. P comes from A naught, and the Q is coming from my initial coefficient. So these numbers are going to multiply to make the 6. These numbers would multiply to make my -4. So let's go down to our specific example here. All the possible rational zeros of 2x cubed minus 11x squared plus 12x plus 9. Well, my rational zeros are going to be, so possible zeros. Well, I know that 9 has factors of plus or minus 9, plus or minus 1, and plus or minus 3. I'm going to divide those by my factors of 2. So I could have plus or minus 2, plus or minus 2 under each, or my same versions, my same numerators, all divided by the other factor of 2, which is 1. And I didn't need to have two pluses or two sets of pluses or minuses there. All right, so these are all the possible factors. I have 6 possibilities, not 6, I have 6 here and 6 here if I include the positives and negatives to test. So let's actually do the testing with this example. So in this example, I want to completely factor this. So I know my possible factors, or my possible zeros, are going to be the factors of -2 divided by the factors of 6. So I'll have plus or minus 2 over 6, 2 over 3, 2 over 2, or 2 over 1, or 1 over all of these values, so 1 over 6, And this reduces to 1/3, so I'm not going to write down 1/3 again. This reduces to 1, so I will write down 1/2. And if I did 1/1, again I would simplify to 1. So I don't want to repeat myself. So in the end I have 1/3, 2/3, 1, 2, 1/6, and 1/2 to test. I'm going to pick the easiest number to test first, and I can test with synthetic division, or I can test by plugging it in and seeing if it equals to 0. So I'm going to start by taking 1, because that's the easiest number, and I'm just going to plug it in. So I'll get 6 plus 11 minus 3 minus 2. That does not equal 0, so I know that 1 is not a root. I'm going to test -1, and I'll get -6 plus 11 plus 3 minus 2. So that's going to be -8 plus 14. That also does not equal 0, so I know it's not a root. I'm going to test my next whole number with this, which is 2, and this one I'm going to do with synthetic division. So I'll have my 6, 11, -3, -2. 6 comes down, I get 12, 23 is 24, that would be 21, so I'll have 42 here. That is definitely not equal to 0. I'll try my -2, 6, 11, -3, -2, -12 is -1, that's going to be +2. I'll get -1 and a +2, and now I have a 0, so that's great. So I know that x plus 2 must have been one of my factors. So I know this is going to be x plus 2 times, now this is going to be x plus 2 times 6x squared minus x minus 1. Well, I can see that this is going to factor to 3x plus 1 times 2x minus 1. And so there's my other factors, 3x plus 1 and 2x minus 1. Note, I can see that means my other factors were going to be +1/2 and -1/3. So those are my other zeros. So if I had tested +1/2 or -1/3, I would have also had a remainder of 0. I can do a quick check also. X times 3x times 2x, 6x cubed. 2 times 1 times -1 is -2.